Okay, let's get started. You've just submitted homework number 7. Your next assignment is due a week from today. And then also, just to keep it kind of fresh in your mind, the project is due on Friday, April 17th. Now, you're definitely going to have more things due between homework 8 and the project, but I'm going to consistently keep announcing the project just so that you don't lose track of that. Remember that at this point, if you're kind of trying to break the project up into pieces, this would be a good time to start thinking about data sources for projecting your income over time, and then also begin to start putting together an estimate of your expenses. That's maybe the biggest part as far as the research goes in the project, is finding good authoritative estimates of probable salary for the crew that you've intended, and then making a estimate of your expenses. Any questions about those announcements? All right. What we're going to do today is look at what happens when you compare the internal rate of return for projects. So remember, in the last class on Friday, what we did was we took a look at a cash flow diagram, and let's just say, for instance, that we have an opportunity for investment, and we invest a certain amount of money, and then that buys us future revenues. The question is, what are you going to do with the money that you get, these annual revenues? Where are they going to be put? And so the annual profit of $50,000 per year, if you're going to be reinvesting it into the same account or into a different account that happens to pay the same rate of return, then you could know what the rate of return is by using the IRR approach, the internal rate of return. But if that's not a possibility, and if instead you're reinvesting these profits into some other account or into a different project that is generating profits at a different rate, then you have to come up with a weighted average of the rates of return, and that's what the external rate of return was. And so today we're going to look at both IRR and ERR in a little bit more detail. But this is kind of the need. This explains or kind of summarizes again why we have to have two different methods for developing the rate of return. So here is that visual summary of what we were doing when we were calculating the external rate of return. Remember that the method was we discounted all of the revenues to the present, all the costs to the present, compounded the revenues to the future, and so that we were aggregating all of the outflows to P, the present, aggregated all of the inflows to the future date, and then we discounted that future amount at some unknown interest rate. It's initially unknown, but we iterate and solve for lots of different I values till we find what is the I value that makes the magnitude of that revenue amount equal to the magnitude of the cost. So that was just the visual summary of what we did to calculate the external rate of return, and this is the template file that you started with in class on Friday to calculate that external rate of return, where you'd be given the external reinvestment rate. That's known, what interest rate you're going to earn when you get the profits and put them somewhere else. That external reinvestment rate is a given, but what you're trying to goal seek and find is the external rate of return. So it's a complicated method, but it enables us to more realistically predict what the rate of return is going to be based on what you're doing with the profits. So internal rate of return analysis can't be used for comparing alternatives. So not only is it limited to projects where you're reinvesting the money, but also internal rate of return can only be used for initial screening. It can't be used for selecting which alternative is best. Now, the definition of the best project is the one that yields the most profit. That's what companies are trying to do, is they're trying to maximize the amount of dollars that they're getting. And what we're going to see in this in-class exercise that we start with is that sometimes the internal rate of return that's the highest isn't for the project that yields the most profit. And so that's why we can't use the internal rate of return for picking which alternative is best. Just because one particular project has the highest IRR doesn't mean you should choose that project. The project you should choose is the one that yields the highest profit. So using the IRR for initial screening will always be valid. It'll always tell you if a project is acceptable or unacceptable when compared to the MAR, but it doesn't always tell you which project is best. So just to summarize again, you can't compare projects by the IRR. You have to look a little bit more closely. All right, so I'm going to give you a handout here where we've got two projects, Project A and Project B. And I'd like you to calculate the internal rate of return for each of them using Excel. And you're not going to use just the easy IRR function. I'd like you to get a little more practice calculating the IRR by iterating the unknown interest rate until you get the sum of the present worths equal to 0. Remember, that's the definition of IRR, is when the inflows and the outflows, when taken to the present, are equal to 0. So you have to try a bunch of guess I values until you finally have the sum of the present worth equal to 0. So you may have your in-class exercise paper from Wednesday of last week, and it's got kind of the template file that shows how to do that. So that's the first step, is find the IRR for both projects. And then to prove to you that IRR can't be used standalone for picking which alternative is best, I'll ask you to calculate the present worth of each of them. So we're finding the internal rate of return for each of them. And just to remind you what it looked like last time we did the internal rate of return, this was the solution from the previous in-class exercise where we had the year, the amount, and then the present worth of the amount at some I value. You add it all up, and then what you're trying to do is change that I value until the sum of the present worths is equal to 0. So that's the definition of the internal rate of return. So now apply that same method for this data set in the handout that I've just given you. So I found the internal rate of return for the first project is 12.4%. Did anybody else get that same value for the IRR? Okay. If you're having trouble remembering what the process is, then maybe you can watch me do it on project B. So I'm starting off with some guess value for the interest rate and then just typing in the known cash flow, 85,000 in expenses, then 14,000 in revenue over the course of 10 years. Find the PV of each year at this guess interest rate that I'm later going to be changing around a bunch of times. I want to find what I value makes the total go down to 0 so that there's balance between the outflows and the inflows. I can manually type that in, or I can do it in an automated way using data, what if analysis, goal seek. The goal is that the total will be equal to 0 by changing the interest rate. So of these two options, it looks like project A has the higher internal rate of return. But the question is, of the two options, which is actually the better project? Which one is going to make more money for the company? Project A or project B? So what we have to do is calculate the present worth. I've given you the factor there on the page. It says P/A factor is 8.1109. So find the present worth of each project. Okay, which project has the higher internal rate of return? Well, according to this, project B has the better internal rate of return. And just remember that we can also do it the easy way. The easy way to find the internal rate of return is just equals IRR, and then you put in the original cash flow, not the present value of the cash flow, but the original cash flow, and it'll calculate that same 12.41 that we got the long way. I just think it's important for you to understand what's happening in the background when you use a complex function like IRR. So of the two options, the internal rate of return that's the highest is for project A. So what that means is that you're earning a 12.41% return on your original investment of $50,000. But here's the thing. It's better to earn 10% on a bigger amount than to earn 12% on a smaller amount. Because project A only allows you to invest $50,000. But you're not trying to maximize some abstract interest rate. What you're trying to do is maximize the dollars that your company can receive. And so the way that we have the proof that project B is better is by looking at the present worths. So let's zoom in here on the present worth calculations. All right, so I gave you the factor of 8.1109. So that's the ratio of P to A. So if we're finding the present worth of both projects, the present worth of project A is going to be its initial cost of $50,000, and then we want to find the present worth of the revenues. And so it's $9,000 each year in revenue, and the factor here to convert an annual recurring revenue into a present worth, that's what that factor means, 8.1109. So if we combine those two things together, combining the original purchase price and the present worth of the revenues, then the present value of option A, when discounted at 4%, which is our MAR, it's $22,998. But project B gives us a higher overall profit rate. Even though it has an initial higher cost, you're also getting additional revenue each year. And so the sum of the present worths for option B is 28,553. And so of those two options, do you want to have 23,000 or do you want to have 28,000? Either one's great, but option B gives you more profit. And so the better of these options, if it's a mutually exclusive alternative, meaning that you have to pick one and you can only pick one, you can't do all the projects that are good, you just choose the best one, option B is better. Yeah.
So say you were in a situation where the project was risky and you wanted to optimize like the risk to reward with a given investment. Would a project then that had a smaller initial investment and a higher rate of return make sense to a certain extent? Just because your ability of losing on it would be smaller?
That's an interesting question. So yeah, there is a lot of uncertainty. Like in this example you've just worked, I told you what these revenues are, and you assume that yes, you are going to make $9,000 every year. But what if there was a chance that maybe you'd only make $7,000 a year? Or maybe, we don't know, or the longer you go, maybe there's more and more uncertainty. And so maybe there's something to be said for the smaller investment if there's uncertainty. But if we can be equally certain about both options, then project B is better. Are there other questions about this? Okay, so what can we use internal rate of return for? Well, we can use it for initial screening. Both of these projects are acceptable because both of them have an internal rate of return that's greater than the MAR. The MAR is 4%. Both of them have an internal rate of return that's greater than the MAR. And so project A will give you profit, and project B will give you a profit. But of the two, project B has the higher profit. And there's this question of what does the present worth represent if you're borrowing money at the minimum attractive rate of return. So remember that the MAR is set by a variety of factors, but the biggest and most important factor in what MAR you use is the weighted average cost of capital. And so how much does it cost your company to go out and raise money? If you're raising it from bond sales, or if you're raising it from private investors who expect a certain rate of return, you're going to have a minimum acceptable rate of return. And the question is, when we did these hand calculations of 23,000 for option A, 28,000 for option B, like what is that amount? And you can see that what I've written there is that if you're discounting at the MAR, then what it means is that this is how much profit this is the present worth of the profit that you get to keep when the loan and the interest for the loan has already been taken care of. So if we added up the total number of dollars, they're going to be a lot more than 23,000 or 28,000 in revenue. But what this represents is the present worth of those dollars that you get to keep when the bank's already been satisfied. Okay, so any questions about the front side of the paper for comparing internal rate of return? So this would be a really good test or quiz question. We were supposed to have a quiz today, but we didn't, right? The reason why is I looked at the in-class exercise for today and I didn't think we'd have time, but I think we'll have time for Wednesday. Today was a false alarm. How many false alarms in a row could I give you?
All of them?
All of them? You're hoping?
Yeah.
So the point is that when to use these methods is almost as important as knowing how to do them, and how to interpret the results is also really important. So on this one, what it showed is that the internal rate of return can be used for initial screening. Both of these were acceptable, and beyond that, we can't choose the option that's best because project A maybe looked like it would be better because it has the higher rate of return, but it's actually project B that gives you the more profit when we look at these present worth calculations. All right, now on the back side of the paper, we're going to get some practice with the external rate of return. So I've given you a cash flow diagram, and we're going to use that same method that you first learned on Friday, where you're going to take all of the costs to the present, the revenues to the future, and you're going to do that at the external reinvestment rate. So that's the known interest rate that you do that discounting and compounding. So in this problem statement, it says that the revenue is put into an account that yields 3.5%. So that's our external reinvestment rate. So that's the known interest rate. And then the last part, where we're trying to relate the sum of the future worths to the sum of the present worths, that's where you're solving for some unknown interest rate, and you have to do it over and over iteratively. I'll bring the template suggestion up in just a moment, but I want to show you year 5. So on year 5, there's both revenue and costs. You need to find the net between them and take only the net to either the present or the future. Because if you ignore the fact that there's a revenue and a cost, and you take the revenue component to the future and the cost component to the present, then you'll get a slightly wrong answer. You'll only get the correct answer if you find the net difference between the two in year 5. Okay? So let me go back to that slide that illustrates the template method for solving external rate of return. This is how we did it last time. Okay, so remember on the external reinvestment rate, that'll be the given interest rate that the profits go to. It's the outside account where these revenues are going to be placed until the end of the study period. The study period is a 9-year time horizon, and what we want to know overall, what is the weighted average of the profits? When you take into account not only the rate at which the profits are being generated, but then the compounding effect. Like this 5,500 that you get in year 2, it's going somewhere, and this 5,500 is going to continue to accumulate additional funds until year 9. And so you're going to be earning the rate that has to do with how much is coming out of the project, and then the weighted average also takes into account that external effect as well from the external reinvestment rate. So what we should find is 17.75% interest. When you go through and do the goal seek, that is the one that makes the sum of the future value of the inflows the same magnitude as the sum of the present value of the outflows. Now you'll notice here for the outflows, by definition, outflows are negative. So I didn't put minus signs, because we already know that an outflow is the opposite direction from an inflow. And so it's only really the magnitude of these that we have to get to match when we're looking for what interest rate brings it into equilibrium. All right, so this next assignment is due on Monday, a week from today. We'll continue talking about rates of return when we get into class on Wednesday. So I will see you then.